Welcome to the Quick Start video for Unit 12, Accelerometer. Here's what we'll cover. We'll introduce the learning goals and featured computer science concepts. We'll call your attention to important preparation for each lesson. And finally, we'll summarize each lesson's main activity. Now, feel free to have the unit materials open as you watch, so you can pause this video at any point to look at them in more detail. Now, during this unit, students will understand how they can use the accelerometer blocks to sense the microbit's position and its movement in 3 dimensions of space. Students will understand the X, the Y, and the Z axis and how we measure gravitational force. And finally, students will research the global goals for sustainability and design a unique program using the accelerometer. So let's talk a little bit about acceleration. Acceleration is basically defined as a change in an object's velocity. And we talk about velocity as an object's current speed, its rate of change along a given axis. So its speed in a certain direction. Acceleration is when any of those things change. So an object could have the same speed but change direction, and that would be a change in acceleration. An object could also be slowing down rapidly, and that deceleration is also a change in the negative direction. So it would be negative acceleration or deceleration. Now, the accelerometer on the microbit detects the microbit's movement along 3 different axes. So we can think of it as the logo up or the logo down. So if the accelerometer flips over, the microbit can detect that. It can also detect if it's tilted. And then, of course, the shake is a custom detection of a certain kind of pattern of movement along multiple axes. And you'll notice that you can have access to an acceleration block, and you can use it in a logic block like an if statement to test if the acceleration exceeds a certain value. You can also use an event handler, such as on shake. And if you click the pull-down menu on shake, you'll notice that the different kinds of acceleration are all listed here. So logo up, logo down, screen down, and so forth. Now for the educational prep, just follow the activity guidelines for the unit level tasks, how to prepare for this unit. The lesson A tasks are given in the Educator guide. The unplugged activity is called strike a pose. The lesson B coding activity is fairly straightforward. The instructions are given in the Educator guide. Students will be coding a Stand Up for Health activity. And then finally for lesson C, the same Educator prep materials are there in the education guide. You'll want to have some crafting materials available for students to prototype their global goals programs. For lesson A's activity, strike a pose, essentially students will take turns choosing a certain pose that everyone else needs to imitate. And sometimes if students are balancing on one leg, they have to change their body position in order to maintain their balance. And it's good for students to understand the relationship between how you detect if you're on balance and how a microbit might detect if it's being moved along a certain axis of movement. Now for this activity, you can either do this in a whole group, have all the kids stand in a circle, or you can break them into small groups of 2 or 3 people, or you can even just have kids work in pairs. For lesson B, students are coding an activity that helps people remember when they need to take a break from work and stand up. And so they can follow the instructions in the lesson B activity to code this app. And in order to actually test it, they're probably going to need to tape the microbit to their leg, as you can see in the photo. For lesson C, we introduced the UN Global Goals for Sustainability, which are 17 global goals, everything from water, clean water, to improving access to resources. Students should research one of those global goals. There's also a microbit site called Do Your Bit, which are lots of examples and activities that are directly related to the UN Global Goals for Sustainability. And ultimately, students will code an activity, code a program that uses the accelerometer and at least one other feature of the microbit that they've already learned about in order to cover one of these global goals. Here are some examples. So this is a Don't Touch Your Face program. Students need to be reminded not to touch their face to try to prevent the transmission of viruses. And so this microbit actually displays a frowny face when you lift the hand up towards your face. This is an example of a pedometer. So this student is using the microbit to detect how many steps they take, because we're supposed to take a certain number of steps every day to maintain our physical health, which is one of the global goals. Now, there are also great examples on the microbit website that students, if they're looking for ideas, they can follow these ideas and code these almost like a lesson B. Here's one called Shake the Bottle. Here's another one that helps you create a relaxation app that helps you learn how to relax. And that's it. This is a fun activity. It's very physical, and you should be able to get kids up and moving around. So we hope you enjoy this unit.